Hello friend, welcome back. In this video, let's talk about a very important concept in any programming language, equatable. Equatable means how can we compare, right? Two objects to make sure they are equal to each other or not. For example, we use a set collection type in for our pieces, right? So here our pieces box, right, is use a set as the container. So the requirement says we need to make the element type hashable, unique. So the uniqueness of the element has to be met. So to guarantee the uniqueness, of course, we need to compare, right? Like element 1, if element 1 is equal to element 2 or any element 3, right? So it means there's a concept of equality inside this type. So when we put a hashable here, because hashable, the protocol hashable inherits the equatable automatically. So like this equatable here is implicitly put here, and by default Xcode will do the compiler synthesize for us. If every property here inside this type is equatable, they will use like to check each one to make sure each property here is equatable, is equal to each other, like from project 1 to project 2. So that's the default implementation provided by the compiler. It's called compiler synthesized implementation. But for us, we know, right? The only significant properties are those 4. Colon, if we know, right? Colon and the row and the prayer, like okay, let me run it. Black and white, right? And the rank, like rook or knight or bishop. If 4 of them are same, we know we can make sure it's a unique piece on the board, right? This is like not necessary. So how do we implement a custom equatable solution? So we can do this static function equal like left hand side. We want to right hand side. We want to compare, right, 2 chess pieces and return Boolean to make sure they are equal to each other, right? So how do we decide the uniqueness? Return. So we know left hand side, this guy, right? The object 1 dot colon equal right hand side column, right? And left hand side row equal right hand side row, and left hand side prayer equals to right hand side prayer, and left hand side rank equals right hand side rank. That's it. We don't need to care about the image name, right? So this should work. This is reasonable. But if we make a decision like unreasonable, okay, let's remove that. So it means, yeah, pretend we just use the column to check the uniqueness of a piece. Now we have trouble. Let's run it. Oh, you see what happened here? Some pieces are missing, right? Yeah, because now inside of the container, the set container, based on this standard, right? Based on this standard, the code cannot make the right decision, like which one they merged some, yeah, with the same column, I think. Yeah, it's messy. Okay, so now let's put it back, undo. So this is a disaster, right? If we messed up with the condition to check the uniqueness. Okay, now run it again. Yeah, they are back. Okay, so because this protocol inherits equatable, so that's why we don't need to put it here, right? It's implicit inside the hashable. Okay, yeah, everything is good. So let me try it again. So for example, if we only put this one there, let's see if, just for fun, right, if we remove that, does it work? Let's see. Okay, it's, yeah, we cannot see the problem, but right, this is an extreme example, so only check rows. Wow, now the set, right, the container set here failed because there's no reasonable way to check the uniqueness of the pieces inside the piece box. That's why we have this trouble, this messy thing. Okay, let's see if we can still move that. Oh, wow, you see? Yeah, it's funny, right? You can play with that. But anyway, let's put it back. The correct thing should be like that. Yeah, we don't need to worry about the image name. Make a decision of, oh, yeah, about the uniqueness. Okay, cool. So this is better than using the compiler synthesized implementation, because I think the compiler synthesized implementation will be that, but that is redundant. Left hand side dot image name equal right hand side dot image name. Yeah, because we know, right, with those conditions we can make sure the uniqueness of any element in a set, so we can save this check. Yeah, great. Let's make a make a commit for that. This is our Mac, okay, chess Mac, okay, git status, okay, we modify that, right? So we can say implement it, protocol equitable equitable protocol for ChessPiece. Okay, so in the next video we'll move forward to implement our own hashable, okay, to replace the default compiler synthesized implementation of the hashable protocol. Git push. Great. Thank you for watching. See you next time.